Hi everyone, let's solve the second question from today's weekly contest, that is increment submatrices by 1. So you are given a positive integer n indicating that we initially have an n cross n zero indexed integer matrix mat filled with zeros, and you are also given a 2D integer array query, and for each query I, row 1 I, column 1 I, row 2 I and column 2 I, you should do the following operation: add 1 to every element in the submatrix with the top left corner and the bottom right corner. That is, add 1 to MAT of xy for all the rows and for all the columns, and then we have to return the matrix MAT after performing every query. Right, so let's see what the problem is. So in this problem we are given a matrix of size n cross n. So 3 n is 3 right now, so the matrix that we will take is this, right? So initially we are given this matrix, then we are given some queries, right? And the queries are given as 1 1 2 2. So basically this one and this one is to represent the upper left corner, that is 1 comma 1. This is for the upper left corner, and this is the bottom right corner, right? So from this is the upper left corner, right? So the upper left corner will be this, and the bottom right corner is this. So basically all these values inside of this matrix, right, we have to increment them by 1. So what we will get, we will get our new matrix after performing the first query as this. This is the new matrix that we will get. Then we will perform the second query on it. The second query says that 0 comma 0 is our upper left corner, and 1 comma 1 is our below right corner, right? So what we have to target, we have to target this cell and this cell. So this matrix we have to increase by 1. So we will get 1 1 1, this will become 2, and rest all the values will be same, right? So this is the resultant matrix that we will get after performing the queries given in this queries array, right? So we can be given a number of queries, and we have to perform these queries onto this matrix. So this is our initial matrix, and we have to keep performing queries and queries, and then we have to just output the resultant matrix, right? So one way to solve this question is just the brute force approach. What we will do, we will take this matrix, then we will query from this point to this point, and we will add all these values, all the one, like increment all these values. And similarly we will go to the second query, and for the second query also we will loop through inside of this matrix and add 1, right, to each and every cell. So that would be giving us a time complexity of the size of this queries matrix, let's say it's q, into will be, performing this operation for a particular query, so that will be n square, right? So this is the time complexity that we will be getting. But as you can see, if you see the constraints here, the constraints given are queries length can be 10 raised power 4 and n is 500, right? So this might give us TLE, right? So we can't go ahead with the brute force approach. We have to optimize a little bit, right? So let's see how we can optimize it. So if we can somehow just mark the cells, right, where we have to increase the value, and from where we have to increase the value and to the point where we have to increment the value. If we can mark all those points, and like we keep on marking those points, and then we move ahead, right? And by the after performing all the queries, if we add, like if we take the prefix sum maybe, or if we just keep on adding, like in some way keep on adding rows or columns, but in some way we obtain this resultant matrix, right? So that can also work fine for us, right? And that will only take q into n time complexity, right? So let's see the algorithm for that. So okay, so let's consider this example only. what we will do is we will create a temporary array of size n plus 2, right? What we want to do is we want to mark the elements, right? We want to mark the points, these points, right? That is what we are trying to do. And by marking these points, we have to, for each and every query, we keep on marking these points. And by the end of all these queries, if we add the like resultant matrix in any fashion that we want to do, then we can obtain the resultant matrix, right? So let's see how we can do it. So what we will do is we will create a matrix of size n plus 2, right? So that matrix will be, right, so this will be the matrix. So this is the matrix, right? Now now what we will do is we will go to these queries, right? So the first query that we have is that 1 comma 1 is the upper left corner and 2 comma 2 is the below right corner, right? So what we'll do is we want to mark in this array, right? So what we'll do is we'll increment this, right? We'll increment this value and also increment this value. Okay, we're just discussing what the algorithm is. We are not discussing how we reach to this approach, we're just discussing what the algorithm is, right? So 2 comma 2 and 3 comma 3. So if you see 2 comma 2 is where 4, right? So it will be 4. So 0, 1, 2, 3 and 4, right? These are the indices. So 2 comma 2 is this part, okay? And 3 comma 3 is this part, right? Now let's see the algorithm. Okay, so here's our algorithm. Okay, so let's see what we are doing in it. So in this algorithm, what we are doing is we are traversing from, as you can see here, let me take another pen. So we are traversing these queries. We have taken the very first query inside of it, right? And we have incremented all the values, right? So just like we did here. And then what we are doing is for this index from the given rows, right? From the upper left row to the bottom right row, right? Sorry, it will be starting from 2 to 3. What we are doing is for both of these rows, we are traversing inside of this loop, right here, and we are doing temp of I y1 plus plus, right? So for the upper left corner, we are incrementing that cell by 1, and for the below right corner, we are decrementing it, to just know that this is the below right and this is the upper right. Oh, sorry, upper left, right? So we'll go from temp I y1 plus plus. So it will be nothing but temp is the name of this array, right? So I is currently 2 and y1 is 2. All right, so we have to increment this value by 1. So where is it? It's this value, right? So what we'll do, we'll increment this value by 1. Okay, then we will go to temp of I y2 plus 1, right? So if we go to temp of I to y2 plus 1, right? y2 plus 1 will be 4. So temp of I2 and 4 will reach here and we will mark it as -1. Then this is for the first iteration, for the very first row, for the row x1, right? For the row I is equal to 2, we have done this. Then we have to go to all the rows, right? If there were 3, 4, 5 rows, for each and every row we had to do this, right? So here we only have 2 rows, so we are only doing it for these 2 rows. So if we go to the second iteration, what we'll be getting, we'll be doing temp of 3, okay? temp of 3, I will become 3 now. And then we are targeting y1 is 2, right? So 3 and 2, this is the cell, so we'll increment this by 1. Okay, we'll increment this by 1. Then we have temp of 3 comma y2 plus 1, that is 4. This cell will decrement by 1, right? So we have done this for the very first query, right? We'll do this again for the second query, right? So let's see the second query. The second query that we have here is 0 comma 0 1 comma 1, right? So what we will do, we will mark 1 comma 1 and 2 comma 2. We have to increment these cells, and then we have to move forward with the algorithm that we are doing. From 1 comma 1 to 2 comma 2 will go, right? So now again we'll come to this loop, right? Right now our I is equal to 1. Okay, our I is 1, so we'll mark temp of 1, right? 1 comma y1, right? y1 is 1, so which cell is it? 1 comma 1, this cell right here. Okay, this cell we have to increment by 1. Okay, then we have to do temp of I will remain same, and y2 plus 1 is 3, right? Temp of 1 comma 3, so that is this cell. What we'll do, we will decrement it by 1. Okay, then so we have done for the first row, right? So this is our first row, this is our second row. So we have done for first row, let's do it for second row as well. So if we do for second row, I will be 2 now, right? I is 2, and we will be marking temp of 2 comma y1, that is 1, and we have to increment it. So this cell is 2 comma 1, so we have to increment this cell right here, 2 comma 1, right? Then we have to go to temp of 2 comma 3, that is y2 plus 1. So 2 comma 3 is this cell, and we have to decrement it by minus 1. After we have done all these markings, we have to target this matrix right here from 1 to 3, right? And we have to calculate the sum of each and every column, sorry, each and every row, right? So what we will do, to calculate the resultant matrix, what we will be doing is, so as you can see here we are traversing inside of this matrix, right? And we are adding the values inside of each and every column. So for the first column, we will get 1 plus 0 is 1, and 1 plus minus 1 is 0. Then for the second row, we will traverse for 1, and for 1 plus 1, this will be 2, and 2 minus 1, it will be 1 only. Then for the third row, we will get 0, 1, and 1. So this is the resultant matrix. And if you match it with the answer given here, that is 1 1 0 1 2 1 0 1 1, so these are the same. So after doing this algorithm, we have reached this resultant matrix. So what we are doing is, we are creating a matrix of n plus 2 size, right? Why are we creating a matrix of n plus 2 size? Because we have to mark, we are incrementing these values, right? So we the need can be to mark up till this point, right? So that is why we are taking a n plus 2 matrix, and then we are traversing inside of this matrix in this fashion, right? And what we are doing is, all the rows, right, all the rows with the left values, we are incrementing them by 1, right? And all the, like, we are kind of giving us that we have to go from this to this part only, but to represent this part we have -1 here, right? To represent this part we have -1 here. So we're decrementing this value, and we are doing this for each and every row, right? So for the first example we had this portion, right? This portion of the matrix that we had to, sorry, this portion of the matrix that we had to increment. So what we did, we marked from here to here, right? We marked from these values. And similarly for the upper matrix, we had to consider these values, right? So we marked from here, right? So this -1 is just to, why are we decrementing? We are decrementing just to know that the previous element is where we have ended, is our limit, right? We have to go up till this point only. That is what we are knowing. And 1 is to know that we are incrementing here, that this is the starting point. This is the starting point, right? So by following this algorithm, we can easily solve this question in a time complexity of, as you can see from here, we are traversing inside of this query, and then we are traversing inside of this. So in the worst case, we will be traversing inside of n rows, right? So it will be n into q, right? And as you know that n is lesser than q, so basically here also we are going from, like, this is n square, right? But n square here it will be less than n into q, right? So the overall time complexity we can say is O of n into q, right? And the space complexity has to be, like, we have to return the matrix, so then it has to be O of n square, right? But we have O of n plus 2 square, but the upper bound if we take of this is, it will be O of n square only, right? Because we do not consider the lower degree polynomial terms. So that is how we have to solve this question. So let's see the code. Although I have explained it there only. So what we are doing is we are traversing inside of these query matrix. We have created this vector, right, of size n plus 2, and we have initialized all its values with 0. And then we are traversing inside of this queries array, and then we are performing this operation, right? We are marking the values with 1 from where they are starting, the left ones, right? And where they are ending are the right values. So we are decrementing there to point out that here to the previous of this we have ended our row or column, right? So that is what we are doing here. And after this, after performing all these operation, we are here calculating the sum of all the columns and putting inside of this another vector v, right? And that is how we have obtained our answer.